Hello dear, how are you? Today we have to solve a problem in which a right angle triangle is given whose area is given which is 8 square centimeter. We have to show that sum of square of these two sides is minimum. We write given that area of triangle is equal to 8 square centimeter. We have to show that sum of square of these two sides, I mean to say square of base plus square of altitude, sum of square of these two sides is minimum. These two given side, base and altitude, let base is equal to x and altitude are perpendicular, which is y. Let S denote the sum of square of these two sides. Sum of square of base and altitude. It means S will be equal to sum of square of base plus altitude, base square plus altitude square, which means x square plus y square. But we know that area of right angle triangle will be equal to 1 by 2 base multiply altitude. You know that area of right angle triangle always will be equal to half multiply base multiply altitudes or triangle or perpendiculars of triangle. Area of right angle triangle. Area of right angled triangle is equal to half base multiply perpendicular. Which is equal to 1 by 2 base, which is x perpendicular or altitude of triangle, which is y. But area of right angle triangle is given, which is 8 square centimeter. We write here value of area of triangle, which is 8. Here we write by multiplying 2 we get 16 is equal to x. But the value of y we write, but the value of y we can write y is equal to 16 by x. 16 by x we know, right? Value of y in this equation. We get s is equal to x square plus y square means 16 by x. Square of 16 by x. After taking square we get s is equal to x square plus 256 by x square. Again we write it. We name this equation 1. To minimize s, we have to differentiate this equation with respect to x. To differentiate, we write s as x square plus 256 x raised power minus 2. By differentiating we get ds by dx 2x minus 2 multiply 256 x raised power minus 3. Here we put ds by dx is equal to 0, implies that this will be equal to 0. 2x minus 2 256 x raised power minus 3 will be equal to 0. Implies that 2x minus 2 256 divided by x cube will be equal to 0. After multiplying by x cube we get 2x raised power 4 minus 2 multiply 256 will be equal to 0. By taking 2 common we get x raised power 4 minus 256 will be equal to 0. 2 easily can be eliminated from here. We get x raised power 4 minus 256 is equal to 0. X raised power 4 is equal to 256. X raised power 4 is equal to 256. We write here 256 as power of 4. We write x raised power 4 is equal to 4 raised power 4. When we raise 4 to the 4, we get 256. Comparing powers, we get x is equal to 4. Now we have to check whether x is minimum or maximum. We have to differentiate. We have to again differentiate s. We write ds by dx, which is 2x minus 2 multiply 256 x raised power minus 3. By again differentiating we get d2s by dx square. We write just 2 derivative of x, which is 1, minus 3 multiply minus 2 we get 6 multiply 256 x raised power minus 4. X raised power minus 4. We write 2 plus 6 multiply 256 by x raised power 4. We now put x equal to 4 in second order derivative. Second order derivative d2s by dx square at x is equal to 4, which is when we put x is equal to 4 here, which will be positive. 2 plus 6 multiply 256 4 raised power 4, because value of x is 4 raised power 4, which will be positive. Hence we write x equal to 4 is minimum. To find minimum s, we put the value of x in equation 1. Put x in 4 in 1 to get minimum value of s. Minimum s will be equal to x square, mean 4 square plus 16 by 4 whole square. square of 4 is 16. 6 by 4, 4 square again 16 is equal to 32. Minimum value of S, which is 32. If we have to find the hypotenuse, length of hypotenuse, this length is the square of hypotenuse. If we want to find the length of just hypotenuse, taking square root on both sides, to find the length of hypotenuse. To find the length of hypotenuse, taking square root, we get S, we write length of hypotenuse. Length of hypotenuse is equal to square of 32. We can write 16 multiplied 2, which is 4 under 2, which is the length of hypotenuse, which is minimum. Thank you.